So good day dear student. Ngayon, try natin makuha yung energy levels and yung solution for the 1D time independent Schrodinger equation of a free particle in one dimension. So mukha siyang mahirap kasi meron tayong mga Schrodinger equations. Pero trust me, medyo madali lang naman siya once na-realize na kung ano yung ginagawa niyo. So for a free particle in one dimension, let's assume that we have a particle of mass m and energy E without an external field applied to that particle. Since there is no external field, we can take the potential energy as constant. And since energy is relative, yung potential energy natin relative, we can take that as just 0. So Ux will be equal to 0. In the time-independent Schrodinger equation in one dimension, we have again, ito yung equation natin. But if U is 0, then we'll be just left with E dito. This is a second order differential equation. And a second order differential equation is something that you should be able to solve since engineering nga tayo. But hindi naman natin scope yon, so I'll just give you the solution for that one. The solution for a second order differential equation from your previous ES21, hopefully, or Math 22, 23, or Math 54, 55 is equal to A exponential I kx, where A is a constant of integration and K is our wave number. And this wave number is equal to, K is equal to 2 pi over lambda, where you guessed it, yung lambda natin is your wavelength. So we can think of the wave number as the reciprocal space analog for your wavelength. And that is why we took on yung reciprocal lattice natin in the previous module. Because in quantum mechanics and in crystals, to find out the properties, we usually deal in reciprocal space. So to solve for the energy of the system, we can substitute back the solution of the wave function, which is equal to A exponential I kx. So the wave function of x is equal to A exponential I kx into our first time-independent one-dimension Schrodinger equation. This one. So A exponential I kx will go into yung wave function of x here. Dito siya pupunta. Substituting, we get ito. We get the second derivative of A exponential I kx with respect to x squared plus 2m h bar squared E times A exponential I kx is equal to 0. From here, we can now isolate E to get the energies permissible for that particle in free space. So we have this. So etong A exponential I kx natin, yung first derivative niyan, d over dx of this one, this will be equal to A exponential of I kx. Then, yung derivative niya sa loob, derivative of something times x is just equal to I k. So, derivative of I kx is just equal to I k. Ito yung chain rule natin, or yan yata yung tawag. And d squared dx squared is equal to A exponential of I kx I k I k. I times I, this is negative 1. I times I is negative 1. K times K is K squared. Then A exponential I kx plus this one here. 2m E A exponential I kx equal to 0. Then, we can isolate for the energy. So, we can move negative K squared A exponential I kx to the other side. So, dito, dayain na natin, equals, and this will be positive. Cancel A. Cancel exponential I kx. You will be left with K squared is equal to 2m over h bar squared E. Or, E is equal to h bar squared k squared over 2m, we get ito. And this is an equation of a parabola. So this is a parabolic relation with respect to E and K. So E is proportional to the square of K. And we'll see that E can assume any value from 0 to infinity and depends on the value of our wave number, K. For quantum mechanical particles, the momentum of that particle is related to its wave number. P is equal to h bar k, where P is the momentum and K again is the wave number. Putting this back in our equation for energy, E is equal to h bar squared k squared, we'll get that E is equal to P squared over 2m. E is equal to P squared over 2m. This is actually similar to the relationship between momentum and energy for classical Newtonian mechanics. So for a free particle, yung energy niya, it depends on the momentum squared over 2m. So this is now the relationship between the energy and the wave number for a free particle in one dimension. So hopefully, naliwanagan kayo dito, and I'll see you in our next video. Thank you.